This is Learning Assessment Problem 3.7. In this problem, we're instructed to use nodal analysis to discover the value of a current I sub O in the circuit. Since nodal analysis develops expressions for voltages in the circuit, we'll have to use an auxiliary equation to determine the current I sub O is equal to V sub O, the node voltage, divided by 3K. There are two voltage sources in this circuit, a 6 volt and a 3 volt source. So we have constraints. We label these nodes V1 and V2. We have that V1 is already known to be 6 volts, and V2 likewise is known to be 3 volts. So with 1, 2, 3, 4 nodes in the circuit, minus one node for the reference, that would suggest 3 node voltages would have to be determined, and 3 node voltage equations would be necessary. We already have 2 of those node voltage equations, these constraint equations, so we just have to develop a node voltage equation at the V0 node. We'll do our summing of currents flowing away from that node being positive, and we'll proceed with the KCL analysis at that node. So KCL at the V sub O node, we have VO minus the V1 voltage, which is known to be 6 volts, divided by 6K, plus the VO divided by 3K for the downward flowing current, and then plus VO minus V2, which is known to be 3 volts, divided by 6K is equal to 0. We rearrange some terms. We have 1 divided by 6K plus 1 divided by 3K plus 1 divided by 6K times the node voltage VO is equal to 6 volts divided by 6K plus 3 volts divided by 6K, which is equal to 3/2 milliamp. On the left-hand side, we have 4 over 6K VO is equal to then 3/2 milliamp, which gives us the result for the node voltage VO equals 2.25 volts. Now we can use the auxiliary equation to determine the desired current I sub O is equal to VO divided by 3K, which is equal to 2.25 volts divided by 3K, which is 0.75 milliamps.